Google developed Carbon programming language with a goal to become a successor to C++. If you want to get started with Carbon language, you're in the right place. In this tutorial, we will learn about what is Carbon language and why is it actually developed. We'll go through a step-by-step process to set up Carbon language in your local dev environment, and then we will walk through some of the basic examples that you can actually try on by the end of this video. Hi everyone, welcome to Tip Season. Tip Season helps you learn latest tech and programming tutorials with simple examples. This video is part of Carbon Language series where you will learn about Carbon language from scratch. Before we get started with Carbon language, here's a quick question for you. What's your favorite programming language? Drop your comment below, and at the end of this video, we will look at the top 10 most loved programming languages of 2022. Alright, let's jump into Carbon language. Let's begin with what is Carbon language. So Carbon language is an open source programming language that is introduced recently at CPP North conference by Google engineer Chandler Karath along with his team. It is still in experimental phase and it is not yet ready for production systems, but you can definitely give it a try to learn the basics of it. Now let's try to understand why do we even need a new language when we have C++ already. To answer this question, let's look at some of the advantages and the real problems with C++. We all know C++ is a very high performance language and is used widely across real production systems. It can even run on multiple platforms, embedded systems, and many servers of different operating systems, right? But then C++ has multiple problems. The first thing is it has a lot of accumulated technical debt that makes it harder to add new features to C++. Because C++ has to be compatible with C, it's really hard to make any kind of new changes to C++ code. The second problem is the evaluation because of the strict ISO process. So C++ standards are maintained by the ISO standards. So if you want to add new modules or new functionalities within C++, it becomes harder as it has to go through multiple approval process. But as we go forward in the future, it's really important for a language to have all the past technical debt to be fixed. At the same time, it should have easy process to add any new kind of features. That's when Carbon language came into picture. If you look at the language evolution, C++ is the successor of C, TypeScript is the successor of JavaScript. Similarly, Swift replaces the Objective-C, Kotlin is the future of Java, and similarly, Carbon language is going to be the successor of C++. Now let's look at some of the key features of Carbon language. The first important feature of Carbon language is the high performance. Biggest goal for Carbon language is to have similar performance of what C++ offers. And then the second important goal for Carbon language is the bidirectional interoperability. What that means is you will be able to invoke the C++ code from the Carbon language. Similarly, you should be able to invoke Carbon language code from C++. And also they added a migration support. What that means is if you have a C++ code, they will provide a set of tools or language level support where it should be very easy to migrate from C++ to Carbon language. And the other important thing is the modern syntax. So Carbon language have a heavy focus on modern syntax. It took inspiration from multiple different languages using a hybrid approach. As part of Carbon language, a lot of evaluation has been done across multiple languages, and they came up with a modern language syntax, which is easy to learn and adapt. So with this background, let's set up Carbon language in our systems and walk through some of the examples that you can use to understand the Carbon language in more detail. In order to get started with Carbon language, there are two options to get started. So the first thing is Carbon language online compiler explorer. So compiler explorer is the fastest way to get started with your Carbon language. It's an online tool where you can actually write the code and compile the entire program online. You don't need to install any separate dependencies in your local system. That's the fastest way to get started to have a feel of Carbon language. Okay, the second option is the Carbon language installation in your local system. So if you have a system like Mac or Linux or Windows, right? Currently, Carbon language has support for macOS. They're adding support for Windows soon. And I've seen some of the people are able to get installation on Linux too. So in this tutorial, we will cover both online compiler explorer and the Carbon language local installation using macOS. We will add future videos for Carbon language installation in Linux, Windows, and so on. So make sure you subscribe to our channel. Let's look at Carbon Online Compiler Explorer. So this is a tool where you can access using this carbon.gobolt.org. So go to this URL. So on the left side, you will see a pane where you can actually write your code. And on the right side, whatever you are seeing here, right? So Carbon language has a way to specify a syntax called trace, which is like the entire debug statements that gets executed for a Carbon language code. So this online Carbon Compiler Explorer gives the entire trace of your code. But for demo purposes, since we need the output of this code, you can see that output in the bottom. So there's a tab where this is the output. So you can just drag and drop to the top. You can just click it and drag and drop. So as you can see, whatever code you write here, it automatically gets compiled and it will give the output here. Okay. So let's say if you want to change hello world, welcome to tip season. So you should see the output printed here. So this is the fastest way to get started with Carbon language. The alternate way to run your Carbon language code is to install the Carbon language in your local environment. So let's look at the process to install Carbon in macOS. Now let's look at how to install Carbon language in our Mac setup. So in Mac, in order to install Carbon, we need to do 4 things. One is you need to install Homebrew. So Homebrew is like a package manager for Mac. If you are used to Linux, the common usage of packages can be achieved using apt-get, right? So the equivalent of apt-get in Mac is Homebrew. So it's like, you can just think of like a simple installation tool for any external libraries. Okay, so in order to set up Mac, all you need to do is just take this command from here and run it in your terminal. Since I have installed Homebrew already, I'm just skipping this step, but you can just enter your root password and it will install Homebrew in your system. So the installation is pretty straightforward. If you want to have detailed instructions of what Homebrew is, you can actually go to this link too and learn more about it. Okay, so once we have Homebrew installed, the next thing we will do is we will install Bazel, LLVM, and Carbon Explorer. Don't worry, it's very easy to learn about them. So the first thing we'll do is we'll install Bazel. So Bazel is like a build tool or the testing tool that is compatible across multiple platforms. So it's an open source tool which can be used to build and test your code. Okay, so many open source projects actually use Bazel for executing their builds. So Carbon language use this Bazel. So in order to install this Bazel, all you need to do is just take this command here and then run it in your terminal. So here, once you have it, it will download all the required libraries and you should have the Bazel installed. Okay, if you see any errors here, when I was originally installing Bazel, I got a permissions issue. So it said like I need to have a root permission for one of the folders. So all I need to do is like run that specific command which is in the output of this Bazel log. It has the actual command that we can run it in order to fix the issue. Okay, so now that we installed Bazel, now let's install LLVM. So what is LLVM? In very simple terms, LLVM is a library for creating machine native code programmatically. It's like a collection of modular and reusable compiler and toolchain technologies that you can use to build new languages. So it actually gives an infrastructure on which any new languages can be built very easily. So if you actually observe Carbon language, right? So Carbon language doesn't yet have a compiler yet. It only has an interpreter. So it uses LLVM as the underlying infrastructure to compile and run its code. Okay, so with that background, let's install LLVM. If you are still curious about LLVM, we'll have a in-depth coverage of future videos, so make sure you drop a comment below. All right, so let's install LLVM. To install that, we need to take this brew install LLVM, and then we will install that. All right, so now that LLVM is installed, so once you install LLVM, right, with brew install, you will see some error messages like this. So basically what this says is macOS by default it comes with a LLVM because of the previous installation of Xcode and all, right? So a lot of people are actually getting stuck at this point. So in order to fix this error, the thing that you need to do is you just go to this page. I have linked that link below. So open your bash profile file. You can do that using vi. Actually, let's clear the screen. So go to your bash profile and then copy all the exact commands that are in this. So the main thing here is we need to set the path, LD flags, CPP flags, and CC. So CC is also very important. I think this is not documented in the original GitHub clearly. So make sure you add this flag in case you are getting the error. So I've made this as which CLang. So actually this gives the location path of where the CLang is installed. Okay, so it will give CLang and I am setting that variable in CC. So take all these commands here and paste it in your bash profile. You can either use a Vim or you can even edit this with a text editor. Okay, so once you have this, save the file, and then the important thing is run the source command. So what this does is it actually compiles the bash profile file so that the changes are getting reflected immediately. Okay, so with this we are done with the LLVM installation. We need to run this one too, which will actually export the path and set the proper path. Now once you have the LLVM ready, next let's go to the exciting part, which is running the hello world. So in order to run hello world program in Carbon language, what you need to do is first you need to clone the Git repository from Carbon. So just take this git clone, git carbon. So what this does is it actually clones all the Carbon command from Git. So here git clone is done. If you see here, the Carbon language directory is created. So go to that Carbon language directory. If you see, these are a bunch of files that came from the Git repo. So basically we just cloned the repository, right? So just go to the Carbon. So the important thing is to be in this folder. Okay, wherever you downloaded your CarbonLang folder using git clone command, make sure you are in that folder. Okay, so once you are in that folder, then run this bazel run this command. So this is the most exciting part. So we will have the Explorer. So just to give some background, so a Carbon language has something called Explorer. So basically it's like a front-end implementation for the entire Carbon language. So if you have to run any specific examples of Carbon language, you can run it using Explorer. So it's similar to like in C++, we use certain tags like GCC or different tags, right? Like for example, in Java, you write Java C and all, right? All that is taken care in Carbon language using the Explorer command. Okay, so let this compile and then let's wait for the result. This might take some time for the first time because it has to download all the libraries. After the first run, the compilation will be much more faster because it actually caches your data in a cached folder. All right, so as you can see that hello world is printed. So finally we've got the hello world working, right? Okay, so now let's actually go and modify that program. So basically if you observe this command, right, what we are doing here is we are doing bazel run explorer. So we are triggering the bazel build to do a run for the explorer tool, And the main thing we are doing is we are giving the argument as this format only .carbon path. So this is the actual file path that is present inside the CarbonLang folder. So if you actually go to CarbonLang, right, the directory structure, there is a folder called Explorer, and then there is test data, and then there is print, right? So this has bunch of examples that you can actually go and try it. Okay, so here if you observe, this is like format underscore only dot carbon. So the actual file format for carbon language is dot carbon. Okay, so if you go and edit the format only dot carbon, you will see that it has the hello world that is written here. So let's go and modify the hello world program. So hello world, welcome to tip season, please subscribe. I'm saving it. So once you save it, if you run this program again, the Bazel, let's copy from here. So I'm running the file. So oh, sorry, I'm actually in the path here already. So I'm actually just removing the path. So Bazel run Explorer, and then you will see here hello world, welcome to tip season, please subscribe. So this is the change that we added here, right? So you can see that whatever change we made to the format only dot carbon, that is compiled properly, and then the output came fine, right? So if you want to go ahead and try any of your examples in this compiler, you can actually go and change your file and specify the path in this format. So basically you have to give Bazel run Explorer hyphen hyphen, and then you specify the file name in which you wrote your actual code. Okay, so this is all about Carbon with Mac. Now that we know how to run Carbon language in our local system as well as the online compiler, for the next part, we will use the Carbon online compiler in order to learn some of the basic syntax and examples. To get started with the Carbon language tutorial with syntax and examples, I'll be following the examples given in this page. Original Carbon language GitHub page also has some of the examples, but some of them are not actually working because the language is still in development. So I'll be following this guide for now, and then we can add more videos in the future. So let's get started. So to get started, go to this page. The link is in the description section, so you can follow along with me. So let's dive into the basics of Carbon language. So in Carbon language, as you can see here, packages are declared using the package keyword. So it's like just like in any other language, we have packages or in a folders, right? So the packages are defined in the package keyword. So within the code file, there should be a main method. Main method should have a return type, or else it will throw a compilation error. So basically it's a way to indicate the language to say like whether this program execution is success or not. And then all the functions are defined with the fn keyword. So even if it is main or any other custom method you write, they should have the keyword called fn. Okay, and comments are written with the double forward slash, like you can see here. So in Carbon language, variables are defined using the var keyword and constants are defined using the let keyword. So the syntax for defining the variables is like var as column, as you can see here. So it should have the var keyword and then the actual variable name. It should follow with a colon. This indicates that the variable declaration is complete, and then the type of the variable. So if you declared auto, the variable type is actually decided by the language, so it will automatically detect whether it is an integer or different kind of data types, right? So auto is the keyword which will detect that, and the value of the variable you can assign on the right side using the equals. Okay, similar to the variable, we can also define constants in the same format. So here also you have to define what kind of variable type it is, and then you can print the variables in using the print command. There is a limited way in which you can actually print the variables. So right now strings can be printed in this format. If it is an integer, you need to append in the curly braces. I will show that in the next examples. And then once you have the method printed, the return type will be 0. So this is the bare bones syntax for the hello world program, right? So now let's actually go and run this example. So we will take this thing, and then we will go to our Carbon compiler. So let's copy paste all the code that we copied from earlier. So as you can see, as soon as I copy the code on the online compiler, it will automatically compile and give the result. So here we defined a variable s, which is the hello world, right? And then let is a constant and y is 3. So here you can see that print s, we did a print the variable for s, so that's why it printed hello world, and then we returned the result as 0. So the result is 1. If you are returning result as 1, you should see that there is a result 1. Now let's try to print what's there in the variable y, right? So in order to print y, if you just print y here, Carbon language, as of now, it throws a compilation error because they're actually expecting a string, but we are giving an input as integer. So in order to solve that, what we will do is we'll have something called these kind of curly braces. So as you can see here, print of 0, this curly braces, and y. If you give in this format, it will take the variable y as the first argument, and then it will print here. So this is a way to print integers. That's what I've figured right now, but there are different other ways, but I think this is much handy as of now. And Carbon language is also adding much more different syntax to support the integers and different kind of printing, right? So the language is still getting ready, so we can explore more. So for now, we will just stick with this method. So now that we learned about variables and constants and how to print them, let's look at the examples for functions, right? So in Carbon, all the functions, as we mentioned earlier, functions are defined using the fn keyword, right? Each function will have a function name or the method name, and then it can have a optional return type. So in this case, as long as the function is not a main function, you can have a return type, or you need not have a return type, which is like the void in many languages, right? So the function sum will return a plus b here. So here we are returning a function of type as integer, okay? And then the function is taking two arguments. One is the variable a and variable b. So here argument a is like an integer and argument b is an integer, and we are returning the sum of it, right? And then we are doing the sum and printing that result in this case, okay? Similarly for print count, you can see that the variable count is, we are printing the count in the method itself. We are not returning anything, which indicates it's a void type, right? So you can just take the syntax and then do it here. So as you see, the sum is 10, which is sum 6 4, which is 10, and the 10 is printed. Similarly, the count is print count, which is actually printing the code within this count method, right? And then the result is 0. So basically that is like the different ways to define functions. Of course, there are multiple ways, but that's like the basic way. Right now, let's look at some of the numerical variables in CarbonLang. So in CarbonLang, there are different variable types. So CarbonLang, just like any other language, they support Boolean, which is bool, which can be defined using true or false. And then for integer types, they have bunch of integer types. So which is like i8, i16. So these are like you can say like 32-bit integer, 62-bit, 64-bit integer, and so on. right? Similarly, if it is an unsigned integer, you can declare using the u, right? Similarly, for float types, you can declare using f16, f32, and all. And Carbon language also supports underscore. So this is like a very good way to separate large numbers. Like for example, if you have a number with so many zeros, you can easily separate them with underscore so that it's easier to read, right? Carbon have this support for this underscore variable, so it's you can just easily define the syntax, or you can actually use it in, I see like many competitive programmers, they follow this pattern so that it's easier to read the code. Okay, so these are the different types of variables. This is just a basic example for variables. Now let's go to the strings. So in Carbon, strings are defined using two things. One is the string type. String is like the byte sequence, just like a string in any other language, right? So you can define a string with the string byte sequence, and also the string view, which is a read-only reference for the byte sequence. Okay, so this string literals can be defined in both single line and multiple line. This is a very interesting part in CarbonLang. In single line, you can declare the string example as hello world in this like double quotes, right? This is supported by many languages, and I think this is like a modern syntax. If you want to define a string with multiple lines, you can define it using the three quotes. Okay, so this is a way to declare the strings. So you can even compile this. Strings can be printed using multi-line. So you just have to leave one extra new line character here. So all the strings that you put it in a block, you have to start with a new line. So this is the syntax for multi-line string. Now let's learn about tuples. So tuples are like, you can think of them as a paired object. So usually it's like a key value pair, or some kind of a pair. So one beauty here is like you can define tuples with multiple coordinates, right? For example, let's say you have a point x comma y. So you can, x comma y is a tuple, right? It's like a two coordinates as x-axis and y-axis, right? It's a single point which is having two coordinates. Similarly, if the point is represented in a three-dimensional world, we'll write it like x comma y comma z, right? So a tuple in Carbon language, it can have multiple coordinates. So you can define them using this x, y, z, this kind of syntax, right? So here x is a tuple, and the way it is defined is using traces of 0 comma 1, right? So this is the syntax for Carbon tuples. You can have multiple syntax. So in order to access that tuple, you can say x of 1. So in this case, 1 is the second element, right? So it's a zero index based tuples. So you'll have x of 1. So we are printing x of 1, and then x of 0 is what we are returning. Okay. So these are tuples in CarbonLang. So if you try to have this printed, we can have tuple with the program printed 1, because 1 is 1, and then similarly if it is 0, we are returning 0. So you can even try to print 0 here, which should print 0. That is tuple. Now the next thing is pointers. So in pointers, so the biggest difference between pointers in Carbon language versus the C++ or other languages is that in Carbon language, by default, all the pointers are like not null. So all the pointers should have a value. If you have to have a pointer with a null value, you should explicitly specify it using the optional keyword. Okay, so keep in mind that in Carbon, all the pointers are not null by default. So they actually kind of mandate it, because they've seen that pointers can have a weird address related problems. Okay, so let's look at a quick example for pointers. So for pointers, we have a bunch of different things here. So we define x is a variable, which is just like a normal variable, right? and then x equal to 10, so we printed x. Now we defined y is a variable which is of type pointer. The reason it is pointer is we added a star at the end, right? And then we are adding the address of x here, we are assigning the address of x here, right? So the value of y we are assigning it as 7, and then we are printing it here. So the pointers can also be accessed using the pointer and address, and these are some more ways you can play around. So pointers always are like tricky things for beginners. The more you play around with it, the easier it becomes. So yeah, just play with multiple of them. Okay, so I've included like three different kinds of examples. The third one is much more complicated program where here you're trying to access the address of a pointer variable y, right? So it is like x is a variable, y is a pointer, and z is a pointer to a pointer, right? That's what we are trying to have it here, and then we are printing the variable values in each of this. Okay, so you can try the syntax. The next thing is arrays. So in Carbon, we can define arrays using the syntax like x array. This is the syntax. So I32 comma 4, right? Semicolon comma 4. You can define array. So in a normal variable, you will define the variable as I32. Like in this case, the right part, this is the normal variable, right? But in case of arrays, we will have the normal variable separated by a semicolon and the size of the array, because arrays are like fixed size, right? So you have to upfront declare the size here. So x array, so the variable array equal to 0156. Here this defines an array with 4 values. So 0156, these are 4 values that are assigned to a array of x array, right? In order to change a specific value, in this case, let's say you want to change the value of the second, right? So you can change it using this syntax. So x array braces square brackets and then index equal to 0. So this is similar to Java or any other language, so that you can just specify the array index inside the square brackets and you can print it, and then we are just printing it. So you can access the array elements using the square brackets. Okay, so you can try out this example at your own. Now the next thing is the if-else conditional statements. Let's look at the example for if-else and if-else if. So in Carbon, the if statement is declared using if in the braces, so it should have a regular braces with a condition inside. So this is similar to the Java syntax, or many languages actually use the syntax, right? So you'll have if and then else. Similarly for if else if, you can write if else, else if, and then finally end with else. Okay, so now let's take an example. For this example, we will have this one. Let's go to this and have this example running. So one thing you have to note is here we are just comparing x equal to 5, right? So if I've tried this for less than, but then Carbon language doesn't have support for the less than yet. It's a known issue. So right now you can try different operations that are involving double equals, which is like comparing the exact left side and right side. Okay, so basically if else follows this if condition x equal to 5. So this is the condition, which if it is true, then we are printing 5, else you can print as unknown, right? So you can see that if 5 is a word is 5, so if it's printed, and then the result we are writing back. Okay, so that is for the if and if else if conditionals. Now let's get into the loops in Carbon language. So in Carbon, there are just like other languages, so they have like while loop and for loop. Okay, so for while loop, the condition is you can have while with a condition inside, and then separated by braces, curly braces. Okay, so for while loop, let's look at an example. We can have, so here you have var x colon auto 5. So we are declaring a variable x, and then for while loop, here the condition is while and then in the brackets you will have the condition. So again, as at the time of this tutorial, the support for less than or greater than is not there for Carbon, so we are just experimenting this with a not condition, right? So here not x equal to 0, which means if x is not equal to 0, then I'm just decrementing. So in that way we can see that 43210, right? We can print this. Okay, so this is the operation for while loop. Okay, similar to while loop, we can write the syntax for loop. Proposed syntax for loop is for where name colon string name in names. So if you look at this for loop, this is similar to the special loops that you are seeing recently, right? So it's like instead of having a index based iteration, you can iterate directly the object variables. So this is just one way to add for loop. As the Carbon language syntax evolves, we'll make more tutorials so that you can actually learn in depth for the for loops and other commonly used scenarios. Now let's look at another interesting case, so which is like match. So Carbon language uses something called match, which is similar to switch case. So in C or C++, you might be seeing switch case, right? So they have support for match. If you are from a Java background, you might be used to the switch keyword, right? So they have support for this match. The syntax is like match, that it will have a condition, and then for each condition there will be a case. If you look at example, that will be more clear. So here where number auto 10, so the match is having the number as condition. So in this case the number is declared as 10, right? So match is taking 10 as input, and it is trying to check whether 10 is equal to 5 or not. So whether 5 k is equal to 5 or not, it will check. If it is true, it will print 5. If it is 10, it will print 10. Okay, in Carbon language, classes can be defined using class keyword. So each class will have a class followed by the class name, and then it can have the member variables, and then the members like class members as well as the methods inside the class. So the variables at the class level can be accessed using this syntax. So here you can see that where p1, which is the variable p1. So in this case, we are having p1 as a variable which is of type sum. So here sum is a class, right? So p1 is having type sum, and then we are initializing the member variable a. Here a is the class member, right? We are initializing that a with 5. Okay, so where p1 equal to sum, which is having the member variable as 5. So this is the class initialization. And then once you have the class, so here we are seeing that p1 is the object for the class sum, right? So you can call the method add using the p1.add here, right? So it's like from the object you're trying to call the method inside the class. Okay, so if you see here inside add method, what we are doing is where total I32, total is a temporary variable, and then we are returning total. Okay, so basically what we are doing is we are fetching the variable a here, which is the class level variable, and then we are adding the sum that is passed in the input, and then we are returning that total. Okay, and then we are printing that total here. Then run this example. So you can see here the total sum is 5. So instead of 5, let's say we are at 15, we can have the output to be changed. So 15 plus 5 is 20, so the total sum is 20. Okay, so that is the syntax for classes. The next thing is structures. So if you are using C++, many of you are very much used to use the structures, right? So structures in Carbon language, they actually help you to identify members using their names instead of their position. In arrays or in linked lists, right, you can access variables within member positions, right? So in structures, you can actually access the variables using the names. So in this case, so variable name is a type of auto which can be a structure too. So the struct is initialized with the following variable. So here dot name1 is a variable inside that structure, dot name2 is a variable inside that structure, Similarly, you can declare multiple variables within the structure, right? So, and you can access those variables using the variable dot. The variable is the actual structure variable, right? So variable dot variable name. Okay, let's see an example. So let's imagine you are having a point, x-axis and y-axis. So a point is a variable of type auto, and it will have two things. One is x-axis and y-axis. Okay, I'm initializing x-axis to 0 and y-axis to 1. So a point, x-axis is 5 and y-axis is -5, right? So the total result is you can access the point using point dot x-axis, so which will give from point, it will take the variable x-axis and then x-axis into x-axis, and then it will return the total sum. Okay, once you call the structure variable, it is just like in any other variable. So using that variable, you can do multiple other operations. Okay, so those are structures in Carbon language. So the next thing we can look at is the generics. So in Carbon language, you can define generics. So this is very unique about Carbon compared to C++. Generics are used in modern languages. So they provide a cleaner way to define what the variables, at the compile time itself, you can specify whether a variable is of a specific type or not. So in Carbon language, generics can be defined using the variable t. So you can say like t colon exclamatory and then type. All right. So now that we know what Carbon language is with the basic syntax, you can actually go ahead and try with all the examples. All these examples are working as you have seen. So you can go ahead and try it. If you find any of the examples are not working, just let me know in your comments. Now, once you learn about this Carbon language, the next thing you might be having in your mind is, when is the actual Carbon language getting released, right? Carbon language is completely in an experimental phase right now. So it's actually at a phase where it doesn't even have a compiler. It is having only an interpreter right now. So all the syntax, all the experimentation, like simple syntax, even the less than or greater than symbol or itself not yet implemented. But the things are moving pretty fast. You can see the community is growing pretty fast and people are contributing a lot. So make sure to subscribe to our channel and hit the bell icon so that you can receive latest updates about Carbon language. Alright, as mentioned in the beginning of this video, Stack Overflow did a developer survey for top 10 most loved languages of 2022. So Rust, Elixir and Clojure are in the top 3. Rest 7 are in the description along with the details on which companies are using them. So go ahead and check them out. Hope you learned the basics of Carbon language with this tutorial. We will soon release more videos to learn Carbon language in depth. So stay tuned. Until then, have a great day. See ya.